All right, let's take a look at the first half of the review here for test 4. We'll start off with just identifying points in their quadrants and plotting points. So point A, from the origin at 0, 0, we would go out 2. So that's the positive direction, so 2 for the x value. And then we would go down 5. Going down puts us in the negative direction. So there we go. As for the quadrants, we use Roman numerals here. This is quadrant 1, quadrant 2, 3, and 4. You may have seen questions where it gives you a very large values. But in quadrant 3, we see that we move to the left, which is negative, and down, which is negative. So every value in quadrant 3 would be a negative x and a negative y. Quadrant A is in, point A is in quadrant 4. I do like to point out that the numbering makes a C. The teacher pointed that out once. Can't help but share it with you. So we start at 1, and then 2, 3, and 4. The path our pen takes as we make a C. So point B is at negative 5 from the origin. Move to the left 5, move up 6. So negative 5, 6 puts us in quadrant 2. I will point out the intercepts, however. Point C is at, we move to the left 7 units. We do not move up or down, so a 0 for the y. And I'll point this out frequently, that if the y value is 0, we are on the x-axis. And then we consider point D. We go down 1, but we did not move to the left or right at all. So a 0 for the x, and then down 1 or negative 1, which puts us on the y-axis. So if we are on an axis, we are not in a quadrant. And then number 2 here, I won't make you watch me plot all of these, but 1, 5, we move from the origin 1 unit to the right because that's positive, 5 units up, and that's point B. And point C here, we would not move to the left or right because the x value is 0. We would move down 6 units. So that's point C. And if the x value is 0, then we have a y-intercept. And then you could figure out the other points, of course. Negative 8, 3 for point A, and 7, negative 2 for point D. So let's move on. Just ignore that. And here's number 3. Again, if we are on the x-axis, we have an x-intercept. So we are at negative 2, 0. If I'm on the x-axis, we moved, in this case, 2 units to the left, so negative 2. We did not move up or down, so the y value is 0. Our y-intercept is right here, hitting the y-axis at 5. So a 5 in the y position, x, y, for an ordered pair. And then we did not move to the left or right. And if we are on the, y-intercept, then our x value must be 0, which is how we can solve number 4. If I'm looking for the x-intercept, then my y value is 0. So we can take our equation here, plug 0 into y. 2 times 0 is 0. It goes away. Negative 3x equals 12. Divide both sides by negative 3. And x equals negative 4. Of course, especially in ALEKS, it will ask for an ordered pair. So negative 4 for the x, 0 for the y. The other way I see this taught is if we're looking for the y-intercept, of course, our x value is 0. And so teachers will just kind of cover up the x term because it zeroes out. You can work it that way. So the x term zeroes out, it goes away. 12 divided by 2 is 6. So if we're on the y-axis, our x value is 0, and we solved for y. And now we look at the x equals graph and the y equals graph. Students will make a mistake here and just put a point at x equals negative 3. We're making a graph. So an x equals equation, put a dot. Well, you don't have to put a dot. In ALEKS, you just make the line that goes through negative 3 on the x-axis. So every point here, just to illustrate, every point has an x value of negative 3. Right here, we're at negative 3, 0. Here, we're at negative 3, negative 4. So every x value is negative 3 on this line. So just make a line that goes through negative 3. And we'll do the opposite for y equals 2. We just make a line that goes through 2 on the y-axis. So I think for some students it's kind of counterintuitive. The y-axis goes up and down, so they think a y equals graph should go up and down. But consider just putting a point at the y value of 2 on the y-axis, and then we make a line that goes through it. And again, every point on this line has a y value of 2. Here we're at 0, 2. Here we're at negative 3, 2, negative 4, 2 as we move along the x-axis. But every point has a y value of 2. So a y equals equation goes horizontal, and x equals equation goes vertical. On number 7, we are graphing in y equals mx plus b form, where m is the slope and b is the y-intercept. So we would hit the y-axis at -3. So here our b value is -3. 0, -3 as a point. Our slope, some students get this confused. If it asks you for the slope, it's just the fraction in front of the x. Don't make the mistake of putting the x in the slope. It's the m value in front of the x. So the slope here is 4/5. That's a positive 4/5. So just to slow down a bit here, we can consider going up 4, that's in the positive direction, and to the right 5, because that's also in the positive direction. But just make sure that a positive slope goes up from left to right. A negative slope should go down from left to right. So if we are in y equals mx plus b form, we start by plotting the y-intercept at 0, -3, and then I follow my slope. I go to plot the next point, I follow my slope. So I go up 4, 1, 2, 3, 4, and then I move to the right 5, 1, 2, 3, 4, 5. And we connect our dots. So in Alex, I think you have to plot 2 points and then your line tool. Or you just select the line tool and then find your 2 points. But there we have it. So again, slope is rise over run. So we went up 4 and to the right 5. Let's keep going. So number 8 here. This is called standard form. AX plus BY equals C. Basically, the variables are on the left, the constant is on the right. It's very easy to graph using the intercept method here. So, what is the x-intercept? If I'm on the x-axis, my y value is 0. So 3x equals 15. Divide the 3, and we get x equals +5. If we're looking for the y-intercept, again, we can kind of just zero out the x term and just consider the y term equals the constant. Divide by 5, and y equals 3. As an ordered pair, 0, 3, but here we're just plotting it. So again, if it's in this form, it's easy to just zero out the y term to find 3x equals 15, divide the 3, and get an x value of 5. It's easy to do the same for the y term. 5y equals 15 gives us y equals 3. And make sure you connect and make a line. Let's look at number 9 here. We're given the equation y equals -4x plus 2. And, there are a few ways to solve these table questions. we can, we're given some x values to consider, and we can plug them into this equation here. Replace x with -2. Bring in the +2. And we use order of operations. -4 times -2. We have to multiply before we add. A negative times a negative is a positive. And then add 2 to that to get a y value of 10. As an ordered pair, -2, 10, which is actually kind of off the graph here. It's easy to test 0. That's always a fun one, because it just zeroes out the x term in this case. 0 plus 2 is just 2. So 0, 2. But we can also use the graphing calculator and go to y equals up here. And we type in negative, not the minus sign, but negative, down at the bottom right. -4, here's my x button right there, +2. Here is the graph. We hit the y-axis at +2, and then a negative slope means we go down 4 and over 1 to get to our next point. But we can go to the table by hitting second graph. And we can move up and down the x-axis, or the x column here. So when x is -2, y is 10. We found that. When x is -1, y is 6. So we can write that down. When x is 0, y is 2. We plug that in. So we can use the table to find our values here as well. And if you're comfortable using the graphing calculator, that's probably how you will do this problem. That's -6 when x is 2. So there's a couple of ways that you can do this. And then we're also graphing this. So again, hit the x-axis at 2, and then the slope is -4. So we can think about that as -4 over 1. So we go down 4 and over 1. And now we have a line that is going down from left to right. So let's see the next one. I'll do this one and then in the video and do a part 2. Oh, how many questions? Yeah, I'll do that. So number 10 here, graph the line passing through the point 0, -4, having a slope of 5. So hopefully by now we recognize 0, -4 as the y-intercept. So we start by plotting at the y-intercept, and then our slope, m, is 5. If we're plotting by hand, we can think about 5 as 5 over 1. So we rise 5 and move to the right 1. And you can do that a couple of times if you'd like. And that makes a line that is going up from left to right. So I'll end part 1 right there, and then we'll pick up for part 2.